The opinions expressed on this radio station, its programs, and its website by the hosts, guests, and call-in listeners or chatters are solely the opinions of the original source who expressed them. They do not necessarily represent the opinions of Revolution Radio and freedomslips.com, its staff, or affiliates. You're listening to Revolution Radio, freedomslips.com, 100% listener-supported radio, and now we return you to your host.
Ladies and gentlemen, welcome back to another edition of Cosmic Catastrophe on Revolution.radio, where, what did they say? The internet never sleeps or something?
Yep. That's it. The internet never sleeps.
We almost had a problem right going to air here. We had another radio show playing over top of our bumper there.
Yeah, I was just thinking about it. I'm thinking perhaps the host of that show didn't realize that the bumper was playing. You know how sometimes we talk over the radio stuff?
Yeah, as long as you keep talking, it doesn't show up.
Yeah, it kind of fades in the background, but maybe it doesn't sound like that on the recorded end. I don't know. Anyway.
Well, ladies and gentlemen, the problem's fixed and we're back. And we have a great show today. We're going to be talking about volcanic explosions and geoengineering and all kinds of fun stuff.
Yes. You didn't introduce yourself.
Oh, I'm Diamond from the Oppenheimer Ranch Project. My lovely partner in crime, Leah Shaper, is joining us.
Hello.
All right. That was a little, all right.
Little disjointed
start
today.
Here. So the topics we're going to talk about, we're going to start off with a new scientific discovery at the Kikai Caldera. Now, this volcano has been known. It's been known to erupt several times in the past, as far back as 170,000 years. But a re-examination of the more recent eruption known as the Akahoya eruption, which occurred 5,284 BCE, which would be about 7,300 years ago. That one may very well be the largest volcanic eruption during the Holocene, and we'll dive into that. After that, we're going to talk about some ridiculous papers in climate science. We'll take a quick look at Antarctic ice, and then the second half of the show, we'll talk about a new cockamamie idea called intentional stratospheric dehydration. We'll get to all those fun things in just a minute. You have anything you'd like to say before we dive in?
I just that we clearly entered idiocracy a long time ago.
Indeed, we did. And interesting side note, right before the show aired, where I was gathering the slides here, a large uptick in seismic activity occurred on the Reykjanes Peninsula. It was clearly similar to other upticks, and I thought maybe an eruption would start. Can you see it here?
Yeah.
But it has calmed down, and up to 10,000 people were watching live and didn't get to see anything yet. But we are just a day or so away to the next phase of this eruption, which will be the 5th eruption on the Reykjanes Peninsula. So good side note there.
Yeah.
So it doesn't look like it's going to erupt today, folks.
Maybe now, not today, but it does look like a good uptick there, though, over a longer term trend, so who knows?
Well, and the inflation on the peninsula has reached the same level as the last 4 eruptions, which means it will erupt any time now.
Mm-hmm.
So let's talk about these headlines that have been all over the last 3 days. This one is very misleading. Underwater volcano eruption 7,300 years ago is the largest in recorded history. Now, any critical
thinker... When did recorded history start?
It definitely started after 7,300 years ago, according to most people. So most people put recorded history at the furthest back 5,000 years.
Yeah. Basically to the old Egyptian dynasties, right? At least how they're recognized.
I guess you could go back 32,000 years and say Lascaux Cave could be recorded history.
Well, I mean, I would certainly argue that, but the typical narrative is not going to do that. So it's funny that they reference an eruption 7,300 years ago and talk about it as if it's in the time frame of recorded history. It is in the time frame of the Holocene.
That's true. And I think they wrote it this way to be more salacious and misleading. Just like they couldn't say it was the largest eruption ever in the world, but this is very close to that by just adding a word, recorded.
Well, right. And I'd say that your average reader is not really going to pick up on that mistake. I'm going to call it a mistake because it is.
Right. And then they show a picture of Hunga Tunga here, which is unrelated to this eruption.
Of course.
But in a much better article from Nature, they actually say submerged volcano eruption was the biggest since the last ice age, which would be much more correct. And they actually show a portion of the volcano, the Kikai Caldera here. So this is a little better representation of actual science and journalism. But let's get into this new discovery, because prior to it, the greatest eruption in human history was Mount Tambora. And now we may have a bigger boom. And so the paper, which the title of the paper has nothing about recorded history in it, which is interesting.
Right.
It just says submarine pyroclastic deposits from a 7.3 kiloyear caldera forming Kikai Akahoya eruption. And so let's talk about the volcano. Did you read the paper?
What bit of it that I could read? I couldn't get the whole paper because it's behind a paywall.
Okay.
But there's a lot of, significant snippets in here.
So this is a piece of the giant caldera that formed during the largest eruption during the Holocene, is what these scientists claim. Now, this caldera complex, some people even put it into supervolcano status, but it is would be then the weakest supervolcano on Earth. So it would have the lowest ranking. So it's somewhere like on the highest non-supervolcano or the lowest supervolcano. Because it's subjective, you can decide. But the reality is, if we were around 7,300 years ago in Japan, it would be very dark days.
It would have been devastating.
Yeah, and we'll get to that in a minute. Now, this volcano has had 3 large eruptive phases since the beginning. The first was 170,000 years ago, and it erupted at VEI 7, and the amount of ejecta during that eruption was about 150 cubic kilometers, which is just about less than half of the more recent eruption we'll get to. The second large eruption. Go ahead.
I'm sorry to interrupt you. I'm seeing 140,000 years ago is the first one that we know of.
Well, there's 2 papers. You pick your dates.
Okay. All right. Fair enough.
There's 3 large eruptions. One is about 170,000. One is 86,000 years ago, which was only VEI 6. And that one only erupted 10 cubic kilometers. So that's a baby.
Yeah.
And then the more recent calculation. Now, they originally had this 5284 BC eruption at about 100 cubic kilometers until they did some studies. And now it is at 394.5 cubic kilometers. That's gigantic.
Yeah.
It's bigger than the smallest of the Yellowstone eruptions. So it's on the par of mini Yellowstone.
Yeah. Well, and then the submarine portion of the ejecta is already more than 71 cubic kilometers. That's just the stuff that's in the ocean.
Yeah, so this is a very explosive eruption that has a lot of material in the air. It's so much material that it can't get that high. It does go, they estimate, to around 14 kilometers, which is like 150,000 feet up. But it was so heavy that what happens is that halfway up, most of the material stopped and began falling at a very high rate in a heated plume. It's called pyroclastic debris flow. And it comes back down on the eruption site, flows down any of the existing islands and into the ocean straight down to the bottom. And it pushed up, they estimate, was it 40 feet or 40 meter tsunami?
Oh, I don't know. I didn't check the tsunami height.
The peer-reviewed papers showed the tsunami ran into parts of Japan as far as 5 kilometers.
Yeesh.
And so anyone that was on so this tiny island is the only remaining part. The original island was huge, 100 times bigger than this. And that's what blew up into the sky and fell back down.
Mm-hmm.
And so similar to Hunga Tonga, which blew a giant caldera out, there's only a little at the rim of the caldera. There's a few islands left. That's what we're looking at here at this caldera, Kikai Caldera. And this volcano does erupt, but it erupts at like VEI 1 to 3. The odds of the caldera erupting in a super volcanic fashion or approaching that, VEI 6 or 7, probably won't happen for around 80,000 years, because that's the periodicity from the known eruptions. Does that make sense?
Yeah.
Do you have any other tidbits on the volcano you want to throw in?
No, I didn't really stuff a lot of the details on this volcano in my head. So,
well, it is if in fact the data is true, it is the biggest eruption in the Holocene. And so we'll leave you links to the full paper here. The biggest Holocene volcanic eruption found by Seabed Survey just came out February 22nd. And we'll link it to you below. But let's take a quick look. Because is this an outlier? No. And we're going to blow your mind just by running through all of the giant eruptions in the last 12,000 years. And that means VEI 5 or greater. Starting with the common error, we just had Hunga Tonga, which comes in at VEI 5. Some put it at low 6. And let's just move down to the first VEI 7, Tambora. Boom. And that was in 1815, 37 to 50 cubic kilometers. So we're talking with the other one, it's 10 times bigger.
yes.
And Tambora was pretty significant. It's the year without a summer.
Right.
So if you multiply that by 10 times, you get, what do you get, a decade without a summer?
Right. I mean, except that for the reason you said earlier, right? Because this is an underwater volcano, we're not going to get as much material in the atmosphere. So the climate impacts are probably going to be a lot less.
Which volcano?
The I always forget the name, the Japan volcano that we were just talking about.
No, it was an island, 150-mile wide island that blew up and is no longer there.
Oh, for some reason I had the complete wrong impression.
That's why that pyroclastic flow happened.
Yeah. Gotcha. No. Yeah.
Yeah. This was a whole island that disappeared in an instant.
Wow. So, I mean, it's really interesting, right? That the only reason that we didn't know that Akahoyo was as big as it was is because we hadn't done the seabed analysis, right? That was what showed how much larger it was than we originally thought.
Yeah. Not only did it show that 70-kilometer debris flow, it showed a hole almost a mile deep. The caldera, I think, is around 15 kilometers wide and 3,800 feet deep. That is the size of the magma chamber that was emptied in the boom. That's a big boom. Yeah. And so the crust became unstable, and then it fell down and made that hole.
Yeah.
Yeah. So it was a big boom. And Tambora would have been they would have been a cratonic volcano, not a subsea or subsurface volcano. That's on land. And so that has a lot of debris too, but 10 times smaller. And that was in 1815. We've got a few VEI 6s, and then Mount Samulus goes back to 1257. So we've got about a 300-year periodicity of VEI 7s. And unfortunately, we're right in that, right? The last one was 210 years ago. So we're approaching the next one.
Yeah. You don't have proxy temperature data handy, do you, to look at 7,300 years ago?
No, but I do have a sulfate graph we can look at, and it was one of the biggest spikes. But we can pull it up. Here's an unknown VEI 7 at 536. It's not unknown. Isn't that crazy? There are two volcanoes, Laki and Lolopongo, right? Ilopongo.
Lolopongo, I think, is in a different time frame. It was originally thought to be the cause of 536, but it wasn't. Isn't that correct? Maybe I'm misremembering that.
Well, we know one of them was Iceland, and what was the other one? I thought it was in the Philippines.
Ilopango, I think, is in South America.
Okay, so go watch our video on 536.
536 AD, because we don't remember what we said.
Yeah, and then prior to that, so this is every about 300 years, a VEI7 topol in New Zealand there. And then we get to BC. Just about every 300 years, VEI7, Deception Island. That happens right around the Roman Empire and the time of Christ. Look at this, more of VEI7 at 2264 BC, Cerro Blanco at 2300 BC, Tal at 3580 BC, Macaulay Island 4360. So VEI7s happen with regular periodicity, not a rare occurrence. Semi-Sopoichinoi in the Aleutians, boom, 8000 BC. And 7300, Shivalush went off too during that time. Oh, actually, this is 5300 BC, right? The new one?
Yeah, 5300 BC, roughly.
Right. It's not even on the chart.
Right.
So that's the background. And here's that sulfate graph I was going to show you. So 7200 would be this one, number 2.
Wow.
Which appears to be the third largest of all the spikes. The largest going off the chart is the end of the Ice Age at about 11.5.
Yeah.
Well, actually, it's showing up at 11 here. So I wonder what that is.
Also, we have 2 big spikes here, 7300 and what is that,
75?
7600?
Yeah, around then.
Yeah. Interesting.
So 7600 is going to be... No. There's nothing on here. Pinatubo? Nothing big enough to do that.
So there's a big volcano that we haven't identified yet.
That's kind of interesting. Based on the sulfate, yeah.
Yeah. Because there's really nothing else that it's going to explain a sulfate spike like that, and it's quite distinct. You know, well, it's not like a continuation.
Sulfates, but here it says non-sea salt sulfate flux. So they can determine if it's volcanic.
Well, also, if it was oceanic in origin, I would guess that the spike wouldn't be that significant. I mean, that distinct is what I mean. Although this is what coming out of...
if a comet or a meteor hit the ocean.
Oh, okay, fair enough. Yeah. And is this coming out of ice core data?
Yes.
Yeah, okay.
That's why it's very specific, very high resolution. So something's happening on these spikes.
Yeah. Yeah.
All right, so do you want to pull up the Holocene temps?
Yeah. Yeah, because that spike is so significant, it's really hard to see how that would not have had a climactic effect. You always have to pick and choose these graphs carefully because, you need to find something that has a resolution that can support what you're looking for.
I think we got it. And
cool.
So what was the time frame?
7300, also 7500 roughly.
Yeah, so there you go. Impossible at that resolution. So at 7300, there are spikes up and down about a degree C. And so that could account for it. But what you want to glean overall in the last 7,000 years is that the temperature goes up and down several degrees all the time.
Yes.
and people don't get it. That's what we call grand minimas often, which make mini ice ages and collapse empires. It literally happens overnight. And so the entire man-made global warming spike fraud is the same as all of these spikes.
Yes. Yes.
So is there a climate emergency? Well, humans lived through all of these spikes and we're still here. We lived through the worst year to be alive, 536 AD. We lived through 27 VEI7s, albeit the people in Japan that were vaporized didn't make it.
Sure.
But we did.
Right. I mean,
it's
part of the reason
interesting to put into context, right?
Yeah. Right. I mean, part of the reason that the climate emergency narrative works is because it's it's not in context, but also it's not in the sense that it's not framed in terms of the historical data, but because we're living such a small snippet of what is on this graph, that in our lifetimes we don't have the ability to see this without looking at the long-term data, right? Like in your lifetime, a small change, somebody can convince you that you need to be alarmist about a small change from summer to summer, but that doesn't account for the grand scheme of things.
Well, what this graph does show is that you could be alive during one of these changes. Take a look at the 8.2 kiloyear rapid cooling event. The temperature dropped 4 degrees C, and right here it dropped 3 degrees C in almost a vertical line.
Yeah, right. So we're still here, and all of the wildlife is still here.
Yeah, but if that happened today, everyone would starve.
Right.
I mean, the way our systems are built, nothing would grow where it's supposed to grow. All the crops would fail. All of the supply chains would fail.
We live in a way that is
squares and cry.
Yeah, I mean, we live in such a way that is completely unadaptable to major shift, but obviously, based on this graph, we do have the ability to do that, and so does the rest of the wildlife. Now, that doesn't mean that you're not going to have species that go extinct, or maybe even new species that arrives in the face of changes like this. But that's part of what living on Earth does. That's just the nature of the thing, and you can't stop that.
Well, and even after the 12,900 kiloyear mass extinction event, a lot of those megafauna made it.
Yeah.
And mammoths lived in some Siberian islands to as recent as around 5,000 years ago.
Yeah, that's amazing.
And so life is resilient, and the shift does hit the fan all the time. Take a look at the Holocene temperature. This is the Greenland ice core data. That's very high resolution proxy temperature. And you can see between the red arrows here, this is not in the ice core data.
Right. Right.
That's the IPCC chart added at the end there.
Yeah. Well, and that in and of itself, that is really, really bad science. To take two completely different data sets and stick them together in a graph. Like you don't
not only
do
that, it's showing a 1.6 degrees C rise, even more than that, 2 C rise since 1880s, since what they call the industrialization. And that's not the temperature rise. It's about 1 degree, 1.1 so far.
Yeah.
So this is actually twice as high as it even actually is.
Yeah. Well, I've noticed too that there's not a tremendous amount of agreement, it seems, in the amount of temperature rise we've actually experienced since 1880. There's the real data, and then there's a bunch of fake data floating around, and a lot of the fake data doesn't agree with the other fake data.
Right. There's some issues with the urban heat island, the fact of where they're taking this temperature data, and so on and so forth. And as Tony Heller puts it out, like the earlier times in our history, 1800s, 1900s to 1950s, there's almost no temperature data, yet they make it up.
Yeah. Yeah. Right.
Like the only data is in North America and Europe.
We're not. What?
Most of the temperature data is North America and Europe, and they make it up for the rest of the world. That's a lot of making up.
That's what I was about to say. It's not like we were collecting temperature data around the world in 1880 and collating in one place. Like that wasn't happening.
Crazy.
So how do we? Yeah.
So let's get into more craziness, and we'll roll into this paper that you're an expert on. The impact of population aging on future temperature-related mortality at different global warming levels.
This paper is ridiculous. Okay, to start with, it's like, it should be titled like, I don't know, Kings and Queens of the Obvious. I can't believe that 18 people signed their names to this paper. So one of the basic premises of this paper is that
old people die.
Old people have a tendency to die when it gets warmer or colder. That's basically what they started with, like a statement that is wildly obvious. And they were like, look, more people die when they're over the age of 65 when it's hot, and more people die over the age of 65 when it's cold. It's like, it's absolutely crazy, right? So and then they have this kind of objection in here where they're saying, well, we know that, but what we haven't modeled is how does an aging population fit into here? Meaning, so the number of people over the age of 65 is projected to rise from 9% right now to 16% in 2050. So they're like, well, nobody's modeled how that affects the level of, quote, excess death. But again, it's like completely obvious, right? If there's more people who are over the age of 65, then you're going to see an increase in excess mortality at extreme temperatures.
So they should be happy about this because all the dead people will be burying. That's just sequestering carbon. I mean, that's great. It's good news. Bill Gates wants to bury trees, but this proves that we're going to be burying people.
Yeah. Well, not only that, but yeah, that's funny. They also acknowledge in this paper that basically that more people die from cold than they do from heat, which is kind of interesting, right? So according to a recent global analysis, non-optimal temperatures, both heat and cold, considering the whole range of observed values, account for more than 5 million deaths globally every year, citing 2000 to 2019, with the burden attributable to cold 9 times greater than that attributable to heat.
Well, that's a big number because the accepted scientific consensus currently is 7x.
Okay, and I think that this is relatively recent. If I recall correctly, this is from a paper from like that fact is from some other paper from like 2021, that analysis.
So that's even more recent, and that's probably more accurate. So 9 times the amount of people die from cold than heat.
Right.
And they're trying to cool the planet.
Right.
Do you hear that?
Right. Yeah. Yeah.
Does everyone out there listening hear that?
Right. So they take that and they're like, okay, but we haven't looked yet at, what does this look like with an aging population, right? And basically what they find out is that, well, let me just read this. It's easier. It is expected that population aging will substantially amplify the future temperature-related impacts by increasing the vulnerability of the populations. A recent review of local and regional temperature-related health impacts found that accounting for population aging could lead to a lower reduction or even an increase in the cold-related mortality burden, resulting in substantial increases in temperature-related mortality. It's weird the way that they keep phrasing things in here. Like they keep acknowledging the fact essentially that more people die from cold than heat, but then they keep lumping it all together with temperature-related mortality, meaning extremes of heat or cold, and like somehow attributing this to global warming. It's completely bizarre, right? And they ran different models.
The title shows, I think, how they got the funding. They've got global warming in the title. They've got mortality. They've got population, impact. I mean, all the big words which get you funded. This is going to be great.
Yeah, the entire paper is like set up in order to get funding, right? Like literally, it seems like the only reason that this was written was to get some funding. It's so bizarre. Where is that? I mean, even this sentence.
We would refer to this as a sharticle.
It's an absolute sharticle. This is, listen to this sentence. A recent nationwide assessment in Switzerland found an increasing trend in the projected cold-related mortality under warmer climates due to an increase in the size of the population at risk when demographic changes were accounted for. It's getting
when
warmer.
it gets warmer, more people die of cold.
Right. And I mean, it's like, okay, now here's the worst. Here's maybe the worst part. So they kind of divvied this up in a number of ways, right? They looked at the stats for what happens at 1.5 degrees C warming, 2 degrees, 3 degrees. They come up with all of these different numbers. They look at it from only the climate changing perspective, and then they look at it from the perspective of adding in the fact that the population is aging and that there'll be more older people. And they do this for 2 different climate models. And it's kind of funny because, like, in one situation, there's in the situation of one of the models, when they include the aging population, there's almost no difference in the mortality rates between cold and warm. But also, there's literally no statistical significance in any of these figures at all. Like, they're completely meaningless. And then it gets even worse, because they talk about the temperature-related mortality rates in different parts of the world. And I got to read this out. I kid you not. This is insane. The largest increase in non-optimal cold and heat combined temperature-related mortality is observed in Vietnam. And then they say 13.2%, with a 95% confidence interval of 2.4% to 30.4%. So they're telling you that there's a 95 out of 100 chance that the excess mortality will be 13.2% within the range of 2.4% to 30.4%.
That's a really accurate study.
Yeah, and then they list a bunch of other figures, right? It's the same thing. Kuwait, 10% with a confidence interval of 0.1 to 17.7%. French Guinea, 24.1% confidence interval, minus 74% to 60.70%.
I'm confident.
It goes on and on and on like this, where they give this enormous range of for how likely this is to happen. Now they say, and they finish their sentence with, despite the highly imprecise estimates. Like, why are you even reporting these numbers? Those confidence intervals that are so wide literally make your numbers completely meaningless. There's no reason to even write about them because there's nothing significant about it at all. It doesn't mean SHIT. It's insane.
Our data plus or minus 100% is so accurate.
It's like, and then there's other things in here, like, they make these statements like, compared with climate, and this is part of this is right in their introduction here, which is obviously written for the media to pick up on. I'll just read it from the introduction. Here we show that at 1.5C, 2C, and 3C of global warming, heat-related mortality, heat-related, right, which is not actually what the data that they came up with. They came up with both heat and cold and all mixed together. Heat-related mortality in 800 locations across 50 countries will increase by 0.5%, 1%, and 2.5%. And by the way, elsewhere in their paper, I found completely different percentages for that. So I don't even know what their answer is, respectively, among which 1 in 5 to 1 in 4 heat-related deaths can be attributed to population aging. I have no idea where they're getting those 1 in 5 and 1 in 4 numbers from. I think there's a footnote that I found for that, but it's like to a paper that seems to be purely about statistics. It's such, I'm blown away by what garbage this is, but it is a great example of how you write a paper solely to get funding, and hope, you're sitting here going, "Oh, the media is going to pick up on this." So you're writing these blurbs that the media will love. The blurbs won't make any sense, kind of like the title of this paper, or kind of like the title of the paper that about the volcano that says that this is the largest volcano in recorded history. Like, It doesn't even matter if it makes sense or not. Like, no one cares. The media
No one
certainly
cares
doesn't
anymore.
care.
No, there is no integrity in science or
No,
journalism. Let's take a look.
No,
Let's jump over here. Very worried. This just came out today. Very worried. Scientists fret as Antarctic sea ice dwindles. Oh my God, they're very worried. I went over to the Arctic Sea Ice Analysis Center because I was worried. And
Yeah.
I saw that in the last 3 weeks, Arctic ice is increasing very rapidly.
Yeah.
I don't know why they'd be worried.
Yeah.
And then I went and looked at the historic average sea ice extent back to the 1980s. This ice shelf is bigger than ever.
Yeah.
And the area that has less ice on the West Antarctic also has 380 volcanoes underneath the ice sheet, shown in red dots.
Oh, but don't you know that global warming also increases volcanic activity?
And if we look at the entire data set, going back since the data was kept, you can see an obvious trend of worry here, straight as it's straight across, and it has no trend up or down.
Is actually, it's pretty flat. It's pretty dang flat.
I don't think you can get a flatter statistical trend than that one.
Right.
But scientists are very worried about this trend. I mean, this is not the first time. This is not the first time. This has been going on for the entire time we've had this channel. That journalists are disingenuous. They don't look at any of the data because no one else is going to look. And can you imagine if they had this title and then right instead of this picture of some ice here on the shore, they put up this graph?
Yeah. Well, and even if you had, I'd say another part of the problem here is that the journalists don't really care. But even if you had journalists that did care, there's a lot of people that don't have any background skills in how to read the data, right? And so they're relying on titles and abstracts of articles to tell them the truth of what's going on. But now we're well, not just now. This has been going on a long time. There's no integrity in the scientific field. I mean, I've talked to you about this many times, but I did part of a graduate program in biomedical writing, and part of my program was to look at. We spent some time looking at abstracts from papers, reading abstracts, and then going and actually reading the papers and discovering that many times the abstracts don't even accurately report what is in the paper. They're reporting on something that is going to get them funding instead. And that lack of integrity, there's also a lot of lying about and manipulation with statistics, right? This is a great way to lie and have people believe you. So you've got journalists who, I guess, think that the scientists are telling them the truth, and so they don't actually need to dig any deeper, but they're not. But also the journalists don't really give a crap. So
yeah, all you need to fill out a grant is the abstract. And so that has to be the abstract if you get the money, regardless of what the paper says. The paper can be completely opposite of because you might find the opposite of your abstract.
Yeah, the frequency with which that happens is really astounding, and I suspect it's only gotten worse in the last decade or two. It's crazy.
Yeah, and what else is crazy?
What?
Geoengineering.
Yeah.
Specifically dehydrating the stratosphere to curb global warming.
That sounds like a great idea.
And they have a caveat in the headline. Yeah. Scientists float the risky new strategy. Well, at least we can admonish them for understanding that geoengineering is probably a bad idea.
Right.
The picture is amazing of this cloud.
Yeah.
Very inspirational. So they say, given the alarm about rising levels of carbon dioxide and methane, it's easy to forget that plain old water vapor is a major greenhouse gas too. Who knew? Now you do. In fact, water vapor can linger for years in the stratosphere, just like Hunga Tunga shot 11% more moisture into the stratosphere than ever before. And so that'll be up there for a while. And it says here, According to one study, a possible jump in water during the 1990s may have boosted global warming up to 30% during that time.
See, this is where I go, I wonder where they got that 30% figure from. And they probably didn't get it from anywhere. It's probably just a made up figure.
They don't, because they used the word may.
Yep.
It may have come from Walmart in Chicago too. So it may have boosted global warming up to 30%, or it may not.
Right. Right.
So that's why we need geoengineering, because it may be bad for us.
Yep.
So we should probably
Right.
experiment with the Earth. Now, the idea between this brilliant geoengineering technique proposed this week in Science Advances targets rising moist air and seeding it with cloud-forming particles right before it crosses to the stratosphere. And what they found this does is it actually dehydrates the stratosphere.
Mm-hmm.
Now, did you get to look at the paper that I sent over?
I did not.
The paper is titled
scanned
Considering Intentional Stratospheric Dehydration for Climate Benefits.
Mm.
The exact opposite of what the title over here says. The scientists float a new risky strategy when the paper says climate benefits.
Right.
Isn't that funny?
Yeah. Yeah.
Because if they wanted funding, they weren't going to write in the abstract that they may destroy the Earth by doing this.
Right.
Probably wouldn't get funded.
Right.
Now, what's even more interesting about this paper is that it's unreadable, even if you're a scientist, because I don't know why they use so many acronyms, but they make an acronym out of everything, every term they invent.
Yeah. Yeah. No, this is
including terms they didn't invent, like water vapor becomes WV. Like, why can't you write water vapor?
Right. Because they're not expecting anybody to actually read this. That's why. Extra text and effort and to write well and write out all the words. No one's going to read it anyway, but it'll get us funding because it looks good.
And they know very little about what they're proposing here, which makes it even more bizarre, because a large portion of the paper is dedicated to what could go wrong. So,
I mean, who would have thought, right? Like, I mean, we talk about this, we have this extremely delusional idea, for example, that we can do things that will outpace the power of the sun to change our climate. I mean, that alone seems so insane to me. Just look at the size of Earth versus the size of the sun, and then some handful of individual elites implementing some practice that is going to somehow overwhelm the power of the sun. It's just absurd. And this is really no different, except that except for the fact that it's extremely risky, because we don't even understand the dynamics of the atmosphere. There's no way to predict exactly what something we do, how that's going to domino effect throughout the rest of the atmosphere and the rest of the planet. Like, you can't predict that, and you can't control it at all.
No.
So to act like we can is insane.
It's like considering we're going to stop the Atlantic meridional overturning circulation. We're going to go out there and we're going to halt the Gulf Stream.
Right.
It's going to save the planet, but that's not what it does. It creates an ice age in Europe. Right.
Imagine like you have a giant bowl of water and you take some food coloring and you drop one drop of food coloring into that bowl of water and saying, I can predict exactly where the color is going to go when in this bowl of water. That's like what this is.
Yeah, but it gets worse, because geologically, we're at the coldest point on Earth that we've ever been. It's the Ice Age. It's happened back a couple times in the geologic past, but this is the coldest Earth has ever been. Earth is usually warmer. And they're suggesting in here, I'm going to read it, that this technique will allow more heat to rapidly escape Earth into space.
Yeah. Yeah.
They literally, we just need a tiny little thing to happen to dive back into the ice age.
Yeah. Yeah. You know, and it's just, it's totally crazy.
All right. So let me read the abstract. We introduce a climate intervention strategy focused on decreasing water vapor, WV. That's the first acronym of 100.
You mean West Virginia?
Yeah. Decreasing water vapor concentrations near the tropopause and in the stratosphere to increase outbound long wave radiation. So they're claiming that if they do this, the planet will cool rapidly. Well, that sounds like a great idea, because we just learned from the last paper that cold kills 9 times more people than heat.
Right. Well, also this is funny too, because we constantly hear now that the sun has nothing to do with the climate on Earth. So where is all of this radiation from that we want to let go of?
Well, according to the climate alarmist models, it's a fixed budget. Earth has a flat Earth heat budget. Has nothing to do with the sun.
Right.
So insane that this is our science.
So where's
now the
this
mechanism
radiation
they
come
want to
from,
use? The mechanism they want to use in this geoengineering is the targeted injection of ice nucleating particles, INPs. Then they don't say what these are.
Mm-hmm.
So they want to
actually
inject.
They do. Somewhere
Oh,
they
okay.
do. It's like,
Okay.
I can't remember, but it's something like a compound I never heard of. It's not barium. It's something triiodide.
Oh, that
So
sounds safe.
They have a compound in mind.
Well, silver iodide is used for nucleating in clouds in the atmosphere.
Yeah, so this is not silver iodide. It's something triiodide. Maybe I can find it. But anyway, keep going.
Okay. So the mechanism is the injection of these ice nucleating particles in air supersaturated with respect to ice at high altitudes at the tropical entryway to the stratosphere. Now, what that means is apparently in certain places on Earth, in the weather systems, there are interactions between different layers of the atmosphere and the stratosphere and the mesosphere. There are mixing areas. So it's just not all the same everywhere on the globe. There are certain places where this mixing occurs more frequently, and that's where they're targeting.
Mm-hmm.
So they want to inject this crap into the supersaturated cells, which will, they don't know what it'll do. It may unleash hell on Earth and create more clouds and make it dark and rain forever and wash us all away. They allude to that in here, but they don't care.
No.
It's going to save the planet. It's going to cool us.
Yes. Well, it reminds me too of maybe 5 years ago when we had another radio show. We did a whole episode about geoengineering with Lee Wheelbarger, and we were talking about the Chinese have a program that they had implemented where they were launching, couldn't find the word, thanks, launching silver iodide rockets off the Tibetan Plateau, hoping to bring more rain to that part of Asia. And one of the things that they readily acknowledged was like, well, by doing this, we may be stealing moisture from the Indian monsoon, which would be completely devastating, right? Like that monsoon is really important. So like, why are we playing with this? We have no idea what this is going to do. It's crazy.
Well, it's just intentional stratospheric dehydration. Come on.
Yeah.
If it gets bad, we'll just squirt some more water up there.
Yeah, right.
Now, they claim that intentional stratospheric dehydration strategy would not counteract a large fraction of the forcing from carbon dioxide because it's just so dangerous and deadly.
It's so powerful.
But then
That's
they use
point-
this word salad here. Ready?
Yeah.
But it may contribute to a portfolio. Like, what is this, an interview? It may contribute to a portfolio of climate interventions by acting with different time and length scales of impact and risk that other interventions that are already under consider. I mean, what are they? That. Wow.
Oh.
Is that a run-on sentence or what?
Well, it's completely meaningless, but I think that's by design, right? It's like smoke and mirrors. Like we're obfuscating the fact that we don't know what the hell we're talking about. We're making it sound good. We're making ourselves sound like the experts so that you and the media will report on this.
So this is the benefit. The benefit of this geoengineering is that it would not counteract a large fraction of the forcing from carbon dioxide, but may contribute to a portfolio of climate interventions by acting with different time and length scales of impact and risk than other interventions. What does that mean?
It sounds like, I've done a lot of work in the nonprofit field in the past, and it sounds like one of these like blathery, policy statements that I would sometimes have to make that like are relatively meaningless. But I'm going to mention that biomedical writing grad program again, because another thing that we were focused on, my advisor was really into this, which I really appreciated. She was, and I was right there with her. She was very much in favor of, because there's a lot of ghost writing that happens in science, right? Like typically you've got your grad students writing these papers. And their motivation is obviously going to be to do well in school and have a good relationship with their professors, et cetera. So they're not going to get too critical. And then sometimes you actually have actual ghostwriters that are hired, so you never learn their names. So she was an advocate of making science writing, like really making it a full-on professional field where the writer is acknowledged by name, and that those people are kind of they almost like serve as the judicial branch, because those people are trained to be able to, like, let's say, read the statistics that are presented in the paper and then go to the author and say, hey, this doesn't really, the way you did this statistical analysis doesn't really hold water. Can you address this or whatever? So almost like serving like as a check and balance in the science. And I was fully in favor of that concept because otherwise this is the garbage that you get.
Yeah, and in order to retract a paper now, it takes a year or more. It already gets published. Everyone reads it. Everyone accepts it. It takes a year for people then to attack it and then for it to be retracted. And nobody knows that that's not a headline. Nobody knows it's a bad paper now.
Right. So if you have like some writers who were both trained and also not invested in the science per se, or the university where it's coming from, or the industry that it benefits, or whatever it is, that would be hugely beneficial. That's obviously not going to happen in this world because there's a lack of interest in truth and integrity. So, but this is the result. This is the garbage that you get, the nonsensical sentences like that don't actually mean anything, but the average person is going to be like, oh, well, that sounds like an expert, but it's over my head. It doesn't have to be like that, It's
not going to affect CO2, but it may affect the portfolio of things that we don't even know what they are and may not do anything anyway.
Right.
Well, how much does that cost?
Yeah.
And here it is. Here's their model and their plan. See here, the red dot, you just shoot off the bomb here near the stratosphere, and then the white bomb goes over South America, does nothing. There's no effect. Everybody's fine, and the Earth is saved. You see that? See that? Reduced humidity and depleted water vapor. We're saved. Like this graph has almost all of their acronyms. Ice nucleating particles, INP, RH. Do you know what that is?
Nope. No idea.
Maybe radiative heat, because they can't write that out. It's too big, the words.
Right.
Because RF is radiative forcing. ISD was intentional stratospheric dehydration. I guess when that scientist made up that term, he was like, "That is my funding genie right there."
Right, right. Well, also that
ISD, baby.
RH has a subfooter as well. RHI, what is that? I can't read that. I1.
RHI, yeah. That's
Yeah,
the induced
so there
RH
must be some
reduction.
other kind of RH.
Yeah, this is the induced RH. So this is the reduction of humidity due to the bomb they set off.
Considering
See how it says here RH synthetic in the red? So that's the fake amount. The normal amount would be the dotted line. The increased amount from the iodide bomb is the red line. Well, we solved the problem.
Look, there's no other variables that they considered in there either.
All we need is a boom in the stratosphere.
Find us tonight on Magnetic Reversal News at 8 p.m. Mountain Time.
Listen to Revolution Radio at freedomslips.com, and we'll be right back after this message.